In the name of God, Fundamental of Thermodynamics, Chapter 17, Compressible Flow, from Borknack and Sontag, 7th edition. Introduction. This chapter deals with the thermodynamic aspect of simple compressible flow. Thermodynamic aspects of simple compressible flow. Through nozzle and passage. Several of the cycles covered in chapters 11 and 12 have flow inside components where it goes through nozzle or diffuser. For instance, a set of nozzle inside a steam turbine converts a high pressure steam flow into a lower pressure, high velocity flow that enters the passage between the rotating blades. After several sections, the flow goes through a diffuser-like chamber and another set of nozzles. The flow in a fan jet has several locations where a high-speed compressible gas flow. It passes first through a diffuser, followed by a fan and compressor, then through passage between turbine blades, and finally exits through a nozzle. A final example of a flow that must be treated as compressible is the flow through a turbocharger in a diesel engine. The flow continues further through the intake system and valve opening to end up in a cylinder. The proper analysis of these processes is important for an accurate evaluation of mass flow rate, the work, heat transfer, or kinetic energy involved. Mass flow rate, work, heat transfer, or kinetic energy. And feed into the design and operating behavior of the overall system. All of the examples mentioned here are complicated with respect to the flow geometry and the flowing media, so we will use a simplifying model. In this chapter, we will treat one-dimensional flow of a pure substance that we will also assume behaves as an ideal gas for most of developments. This allows us to focus on the important aspect of a compressible flow, which is influenced by the sonic velocity, and the Mach number appears as an important variable for this type of flow. Mach number. This is an introduction. The first section is the stagnation property.